Hi, so welcome to this lesson of our study of linear algebra, and so we've gone through a lot of different approaches to solve systems of linear equation, and one of them is the row reduced echelon form, where you after reduction you use back substitution to solve for your system. Okay, and some of them gave that we had conditions where a system would give a unique solution, where a system will have infinitely many solution and no solution. So today what we're going to do is to know and learn how to use Python to actually solve all these things that we are talking about. Okay, so let's say I have these systems here. I want to write a Python code that will be able to solve this system. The first one, show that the system is a unique solution and go ahead and solve it. And the second one is infinitely many solution and then no solution. Okay, we have to write a code that will be able to tell us all these things. And we are not going to write everything from scratch. We're going to leverage on this Python package called Sympy, which is designed for symbolic math calculations like these in Python. In fact, you can actually use that for integration, differentiation, limits, and a whole lot of operations and calculations that you want to solve in math. Okay, and as time goes on, as we do other courses, I will take my time to also show you the Python aspect of how you can solve those things using Python, specifically using Sympy. Okay, so now let's go to Python and program. Okay, so I'm gonna write some Python codes here, and like I said, we're just using this to solve a system of linear equation. So the first thing we have to do in Python, if you want to use a library, we have to call it. So from Sympy, I'm going to import. So luckily for me, I'm using PyCharm. So PyCharm provides all these things so that you can use them. It just gives you the next thing that you're supposed to write. You can actually use Spider. You can use Jupyter Notebook if you are using Anaconda, or maybe Visual VS Code or something. So like whichever ID you want to work in, that's okay for me. You just have to have your Python installed. You have to have your package, this package Sympy, for instance. If you are not using Anaconda, you just have to make sure you've installed that Sympy. Okay. And then what we are going to do, see here, what I'm going to write is I want to get so I want to prompt the user. So I want to make sure that I'm writing a user input code which will ask the user to tell us the number of equations that we have. So I want to have get the number of equations, right? So what I'm doing here is I want to prompt the user that there's something called number of equation, and that is an integer as well, right? And it's an input that is going to take, and I want the user to, so I want this to display. I mean, I'm just hoping that you know Python a little bit, right? So luckily for me, Sympy, so I said Sympy, PyCharm will provide all these for me, and then I'll just type it, right? So we want to give the opportunity for the user to tell us how many equations are we solving, right? And in this case, all the examples I wanted to solve, there are only 3 equations in both, all right? And then number of variables. So I want the user to also tell us. Luckily, like I said, PyCharm will provide all these things. So I just hit tab and then it added. Okay. So number of variables, the user will be asked to enter the number of variables that they are dealing with. Maybe you are doing a 10 by 10 matrix, or maybe a 10 equation with 10 unknowns. So the number of variables here in that case will be 10 variables. But luckily, all the system we've been solving so far are 3 unknowns with 3 equations. Okay. We want to generate something. So I want to generate the variables name. So in Sympy, one of the things that you're supposed to do is make sure you define your symbols, right? So what one of the things I'm trying to say here is that something like x1, x2, the rest all the way to xn, right? So maybe you have n number of equations, so you want to generate a variable names. Okay, so I want to call this variables, and that's equal to symbols, right? And then the symbols, I want to I'm not just going to use x, I'm going to use something we call the fprint in Python to define these, that x1 is to the number of variables. Okay, right? Luckily Sympy has I said Sympy, PyCharm has it. Now the reason I'm doing this is Python will start counting from this and not add the ending one, right? That's why I've added a 1 to it, so that if my number of variables is 3, if I add 1, it's going to start from x1 all the way to x3, because I will have x1 all the way to this will give me 4 if my number of variables is 3, and Python will not count the last one, right? So we know all these things. I'm just hoping that you know these Python stuffs, right? And then I want to have a list of equations. So I want to have an equation system of equations. So I want to say that list of equations, and in that I will define this equation. Equations equals, I'm just defining it, right? So that we'll store that's every equation we get, we store it inside this this list of equation. Okay, so I mean, I want to tell the user to enter each equation, right? So I want to, what I'm doing is I want to get a user input code. Okay, a code that it will ask the user to type certain things. And like I said, I'm just hoping that you know something little about Python. Okay, so I want to say this is what I want to tell the user, that say, hey, enter each equation, right, using variables. All right, so we have variables x1 to x1 to x of, we have number of variables, but we will not add 1 to it. Okay, and then in that case I want to say example is that you want to type an equation something like this, right? I'm sorry, you want to type an equation in this format, x1 plus maybe 2 times x2. I mean, this will give you a guide to know how to go about these things. 3 times x3 equals 5. Okay, so this is an example equation that you may want to type as the user. Okay, and now we're going to use a for loop here. So we're going to have for every number of I in every for I in the range of the number of equations. So for every equation that you have, type it. That's what we're going to do. So for I, in range number of equation, right? So we have the number of equation here. So we want to have equation, and it's going to be in a string form, but you can just input. So I want the user to write this, enter equation I plus 1. Now the reason is Python is going to start counting from 0, right? So definitely once it's start counting from 0 and you want the equation 1, it will start with 0 plus 1, which will give you equation 1. All right, and now the next thing is to split So what we're going to do, we're going to split the equation into the right and left side so that we'll have a system of equation. I would talk about that, or maybe if you've really followed the whole lesson that we've been doing, you can write your system of equation into a matrix times some x equals the vector b on the other side, right? So you have ax equals b. So you want to split your equation into the matrix side and then the b side, okay? Our equation at the equality part, okay? So you want to split this at the equality part to separate the left and the right parts, okay? So once you had we have this, so this is what we're going to do: left part, okay, and right parts. So luckily we have something that is being given to us by PyCharm, but like I said, with this part, it's saying left part, right part equals equation change dot split. So you're going to split it into left and right at the equality part, okay? So that's what you should. Now you want to convert these things, these left and right parts, into some Sympy expression that we can use this Sympy library that we just imported before. Remember, we imported Sympy. From Sympy, you imported all this star. This star there means that you're importing all the functions like symbols, the splits, and those things, right? So if you didn't import that, you would have to use Sympy.split, which is going to be a long thing, okay? So want to convert this, so if you maybe you may forget about that, so I want to convert both expressions into Sympy expression, or maybe both parts into Sympy expressions or something, and form an equation, right? So we want to make sure that Sympy understands what we are doing. So we want to say that the left expression should be equal to simplify. So I want to simplify this left part dot strip. So all these things are just like I said, it's just the Python code, that command that we're supposed to use. Dot strip. When you do that, we want to have locals because we define some dictionary here. String variable is to the variable for variable in variables, okay? So var in variables. So this is what we want to do. I mean, I'm saying all these things are codes that, or commands that we use in solving these, okay? And luckily we just go to the right expression. All right, so we go again and then we use the same thing that we did, local, right? We do the same thing on the right parts of the equation, okay? So once we have these things, the next thing we'll do is to form the equation. Say that equation is equal to this equation here, this capital EQ is a Sympy something that we should also have, okay? So that's what I have, and now I want to add this equation that we've actually typed. I want to add it to my equation list, okay? This equation. So this whole thing, we just pick one equation, add it to this list, and then run it, okay? Now what do we want to do? We want to solve the whole system, okay? So this is what you're going to do: solve the system of equations, okay? Now solution, I'm going to name the solution to be just solution equals linear solve. So this is len solve, and then you define your equations and you define the symbols that you are using. So these are all stuff that you get. Now I want to get the output results. Okay, so the results I want to get is that I want to make sure that if the system has a unique solution, this is what it should happen. If the system has infinitely many solutions, this is what it should do. Okay, so we have the outputs. Output the results. So this is what we're going to output here. So if not solution, so this is also, like I said, a something we get from Sympy. Okay, print maybe the system has no solution, or maybe no solution. Right, so you say that, and then or if elif any, right, is in, right, instance solution list for solution in solution, right? So what we are doing, so if the solution you have for every solution you have in the solution is a free variable, right, free underscore symbols. Like I said, all these things are stuffs that comes with the Sympy package, and that is the beauty of it. Okay, print the system has infinitely many solutions. All right, so the system has infinitely many solutions, and then we're going to print that solution. Right, print solutions, or maybe for s in, yeah, let me write it that way. And for s in solution, print s, sorry. Okay, so if all these two things do not happen, then the next thing is to print if you don't have a solution, does not happen, and if the system the command that say the system has infinitely many solutions does not also work, then obviously the system has a unique solution, or maybe one solution. Okay, we are used to a unique solution, right? So let's use the unique solution for the meantime, and then for s in the solution, just print s. Okay, so this is the code that we're going to use to run this. We can first of all run this and see if it works. If there are errors, then we're going to debug it. Okay, so let's run this, and after running we have enter number of equations, so boom, it works. Okay, so I'm going to do another video how I'm going to use this code to solve my system. Okay, all right, see you in our next lesson.